Hey, welcome to Unit 4, Section 2. We're looking at solving systems of equations algebraically. There are two ways to do it. There's a lot to do, most of the time we do something cute and fancy, put a little video clip in there, but you know what?
Ain't nobody got time for that.
That's right. Ain't no one got time for that. So we're just going to get started here. We have the first example, takes us back to the lesson we just did in Section 1, solving linear systems by graphing. So what I want you to do is pause the video and solve this system by graphing. We're pausing already. Go! Okay, we're back, and hopefully you solved it the same way that I did. If you solve each equation for y, look what we get here. So the first one, we divide everything by 4. We get y equals 2 minus 3/4 x. You can rearrange the terms if you want. We have m equal to negative 3/4 b. That means you got to go down 3 and over 4. b is 2, so you start here at 2 and you go down 3 over 4. That puts us over here right about that position there. And the other line, we add x to each side. We get 1x plus 1. All right, so you go up 1 and then you go up 1 over 1 from there. All right, so if you notice, our two equations, they intersect in the middle of no man's land. Oh, man, I don't know what point that is. And I could zoom in if I wanted to, but guess what?
Ain't nobody got time for that.
That's right. So we need to learn a different way to do this. All right, so that's where substitution and elimination come in. Okay, substitution is best used when we have one variable that can easily be isolated, which means you can get one variable by itself easily. Elimination is when the variables line up, and you can see what happens when we go through some examples there. Both can be used to solve any system of linear equations, but usually one method will be better than the other one. All right, let's look at some examples. Okay, the first example we're going to look at is called substitution, and that's where you do what? Oh, substitute. That's right. We're going to look right here. We have 4y equals 8 minus 3x, and then we have y minus x equals 1. Okay, so what do you have to do here? You have to get one of the variables all by itself. Okay, when possible, solve for a variable that has a coefficient of 1. So I see this y right here, and I'm like, I can get that by itself pretty easily. So I go y minus x equals 1. Then if I do a plus x and a plus x to each side, they cancel out. We get y equals x plus 1. The substitution comes in when you say, hey, wait a second. This is y, and y is equal to x plus 1. If I go back to the other equation, I can take out the y right here, and I can put in the x plus 1. So if I write that equation, I get 4 times y. Well, I'm not going to use y. I'm going to use x plus 1. Okay, will equal, and then I write the rest of the equation right here. 8 minus 3x. Okay, so now it's just distributive property. 4x plus 4 equals 8 minus 3x. I'm going to add 3x to each side and subtract 4 from each side. Let's do that. Plus 3x plus 3x. What do we get? 7x plus 4 equals 8. You're going to get 7x equals 4 if we subtract 4 from each side. X is 4/7. Ouch, that's ugly. Let's go back to either equation. I'm going to give you 3 choices here in purple. You got this equation, you got this equation, or you got your new transformed equation. You can go and plug in our answer here, which is x equals 4/7, to either one of those. I'm going to pick the third choice here because that looks the most simple out of all the choices. So y equals x plus 1. Y is going to equal 4/7 because that's what we got for x plus 1. What's 4/7 plus 1? Oh, that's 11/7. You guys know your fractions. So the answer for this one's going to be x equals 4/7 and y is going to equal 11/7. That's an ugly fraction, but you know what? It is what it is. So in conclusion here, you get one of the variables by itself. In this case, we get y. Take whatever that's equal to and plug it in the other equation. Okay, you can't plug it in the original equation that you transformed. You got to go in the other equation with it. Once you do that, distributive property, combined like terms, that kind of stuff, and you're good with substitution. How about that?
Ain't nobody got time for that.
All right, example 2. We have y equals 2x minus 9 and negative 3x equals blah, blah, blah. Doesn't matter because the first equation is already solved for y. So I'm going to put a little box around it. Okay, y equals 2x minus 9. In the other equation, I'm going to put, instead of y, I'm going to put 2x minus 9. I don't have to solve either equation for a variable because it's already done for me. It's done in the first equation here. So I'm going to put that 2x minus 9 in for the y. Now let's look. There's a minus in front. So what's that going to look like? negative 3x equals negative 15 minus, and now we need to subtract all of y, which means we subtract the whole quantity 2x minus 9. Alright, so now what? We substituted in for y. Here's a minus. This is just like our previous skills, back to basic algebra skills. Alright, negative 3x equals negative 15. That negative sign goes to both. So we're going to have minus 2x, and we're going to have a positive 9 because it's negative times a negative is positive 9. Okay, so now what? Remember the smallest, well, let's get rid of this 2x here. Let's add 2x to each side. I was going to say the smallest variable, but we have some combining like terms to do. We're going to have negative 1x equals, they're going to cancel out, negative 15 plus 9. That's going to be negative 6. You're going to get x equals 6. Alright, so now pick one of the first equations. I'm going to pick the first one because it's pretty simple. Y equals 2x minus 9. Alright, x is equal to 6. So wherever you see an x, guess what you put? A 6. So we're going to get y equals 12 minus 9, or 3. So our final answer for example 2, 6, 3, write it as a coordinate point. Let's circle it so the grader knows what we're doing. Alright, that's example 2. Let's go on to example 3. If you notice example 3, you have both equations. I'm going to look right here. Here's the x, that's by itself. So I'm going to rewrite the second equation. This seems to be the easiest. If I subtract 8y from each side of the equation, draw a line, they cancel, I'm going to get x equals 10 minus 8y, or I'm going to write negative 8y plus 10. That's just how I like to write it. So now I go back to the other equation right here. See the x? Alright, here's x equals, alright, so you go back to the other equation. Let's write that out. Negative 3x minus y equals negative 30. Instead of x, I'm going to write negative 8y plus 10. So negative 3 times x, which we know is negative 8y plus 10. Alright, that's the x part. That's right there. Minus y equals negative 30. Now I have only y's in here, but we do need to be careful with our negatives. When we distribute, we have negative 3 times negative 8. That's positive 24. Negative 3 times 10 is a minus 30. We have a minus y hanging out. All of that equals negative 30. Alright, so we get 23y, because we combine 24 and negative 1, minus 30 equals negative 30. If we add 30 to both sides, 23y equals 0, or you're going to divide and get y equals 0. So now I'm going to go back to this equation right here. Let's change the color. Let's go back to this equation right there. So we get x equals negative 8y plus 10. But y is 0. So x is going to equal negative 8 times y is 0. Look at that. That's what we're talking about. Negative 8 times 0 is 0 plus 10. All that equals 10. We're going to get x equals 10. So the final answer for this one, 10, 0. Now, we haven't talked about this, but if I wanted to graph these two lines, where would they intersect? 10, 0. If I wanted to plug this point into both equations, what do we get? Negative 3 times 10, that's negative 30, minus 0, that's negative 30. All right, and 10 plus 8 times 0 is 10. So it works in both equations. We know it's a solution of both. All right, there's example 3. On to method number 2, which is elimination. Okay, so elimination, you want to get two of the variables to cancel out. And how do we do that? We add them and we make them opposites if we need to. Or sometimes they're already opposites. Let's look at the first example. Okay, if we look, by the way, you can go to Algebra 1, Section 8.3 if you need more help with this. But if we notice these two equations, first thing we have to do is make sure everything's lined up. We have the x's lined up on top of the x's. We have the y's on top of the y's, the equal sign, and these are called constants. They're on top of each other. So we're good there. All right, do we have opposites? Is 2 the opposite of negative 3? No. Is negative y the opposite of positive y? Yes. Okay, so if we have opposites, we can just add the equations. And we're going to eliminate when the two terms that are opposites, when they cancel out, we're going to eliminate them. So let's see how that looks like. All right, 2x minus 3x. That's going to be a negative 1x. These cancel each other. The equal sign comes down and we get a negative 6. That's easy to solve. You get x equals 6. All right, now we can take it and plug it back into either equation. I'm going to pick the first one because it has less negatives in it, but we have 2x minus y equals 9. All right, we figured out that x equals 6, so we're going to plug that in right there. So 2 times 6 minus y equals 9. This is 12, so 12 minus y equals 9. Subtract 12 from each side. We'll get negative y equals negative 3, or y equals 3. So the first example, by elimination, we solve it. We get 6, 3, x is 6, y is 3. And again, we do that by finding opposites and then just adding the equations. Okay, the steps are written down right here for you to read through. Let's try 2 more examples. All right, so I look at example 5. The x's are lined up, the y's are lined up, and the constants are lined up. So everything's good to go. I cannot find anything that cancels, though, because I look, a negative 10 and a positive 3, they don't cancel. 8 and 1 don't cancel. But what I can do is I can multiply one of the equations. I'm going to multiply the second equation by negative 8. And the reason why you do that is because I see that y will turn into a negative 8y if I do that. Okay, you have to multiply everything, though. You just can't multiply one term. You have to multiply the entire equation. Let's do that right now. We get negative 24x. Okay, that's the first term. The next term would be minus 8x, or I'm sorry, 8y, my B, equals, what do we get here? 4 times 50, that'd be 120, negative 120 there. All right, we're good. I'm going to rewrite the first equation all over again. So let's just write that down exactly as it is. Negative 10x plus 8y. And if you notice, those y's are ready to cancel right now. All right, so I'm going to add the 2 equations. At this point, negative 24 and negative 10 is negative 34. So we get negative 34x. These cancel out. Equal sign comes down. We get negative 136. And we get what? X equals 4 for that. Okay, it'll work out. You divide by negative 34 both sides, you get x equals 4. Then you can go back. I'm going to pick the second equation again because the second equation has less negatives in it. I don't like those negatives, and I found that x equals 4, so I'm going to plug that in right here. So 3 times, we know x equals 4, plus y equals 15. That's going to give us a 12 again. This just happened in the last problem, didn't it? Okay, subtract 12 from each side, y equals 3. All right, so that's example 5. We're going to get x equals 4, y equals 3. We write our answer as a coordinate point. Let's go on to example 6. You try example 6, but I'm going to warn you, in the second equation, you have to move the 2y over first so things line up. So pause the video and try example 6. Go! Okay, we're back, and hopefully you were able to move that 2y over. You do minus 2y to both sides. You get 10x minus 2y equals 22. Let's rewrite the first equation right there. And there's the first equation. We add them together. The y's cancel. We get 11x equals 33. And, of course, x equals 3. So then I'm going to use the first equation because it's simpler. I'm going to plug into the x. We get a 3. And then subtract 3 from each side. We get 2y equals 8 or y equals 4. So the answer, the solution to this system of equations is 3, 4. And we're done with that one. That's example 6. All right, let's look at 7 and 8 because sometimes we need different tricks to solve these. All right, 7, I'm going to multiply. There's too many negatives here. Let's just multiply this by negative 1. I don't even know if I'm going to do substitution or elimination yet, but I'm allowed to multiply this equation and change the form of it. It's equivalent, so I can do that. So I'm going to multiply everything by negative 1, and I'm going to get x equals 11 plus 4y. That just looks better. All right, now I'm going to take the second equation, and I notice all these fractions, kind of like back in the first unit when we went over that. I remember I taught you that stuff. I'm going to multiply everything by the common multiple, the least common multiple of 3 and 2. Remember, this is over 1, so that's going to be a 6. If I multiply everything by 6, this becomes a piece of cake. Okay, so these would cancel. It'd leave a what? We get 3 goes in 3 once, 3 goes in 6 twice. 2 times negative 2 is negative 4. X, and then half of 6 is 3, so we get minus 3y equals negative 6. Okay, because you can't forget to do that last term. That's what a lot of students do. And at this point, you can do substitution or elimination. You can move that 4y over if you want, and then continue with elimination. But I think this one's a little bit easier to do by substitution because we have x all by itself. So I'm going to write down negative 4. Here's the second equation.
Ain't nobody got time for that.
I'm using substitution. So I'm going to, x is equal to 11 plus 4y. I'm going to put that in parentheses. 11 plus 4y. Okay, that's the x. That's what that is right there. Okay, we subtract 3y, and all that equals negative 6. So now it just becomes an algebra party. Yeah, we just start distributing like we know how to do. Combining like terms like we know how to do. Alright, we're going to get negative 44 minus 19y. Okay, equals negative 6. Whoops. Alright, negative 19y equals 38. When you add 44 to each side, you get y equals negative 2. I then take the first equation here. We have x equals 11 plus 4y. I got y is negative 2, so I'm going to plug that in right there. So x is going to equal 11 plus 4 times negative 2. And that works out to what? 3. All right, so x equals 3. Solution to this system is 3, negative 2. By the way, I'm going to tell you now, some of your homework answers are decimals. Okay, let's look at number 8 here. I'm going to use elimination on this. I can tell because the x's are lined up, the y's are lined up, and the constants are lined up, the equal signs. Everything's good to go, but nothing's going to cancel. Furthermore, I can't really multiply either equation by something to make the terms cancel if I use one step. But in 2 steps, I think I can do it. Let's look. Which ones do you want to cancel? The x or the y? The x. Let's cancel the x's because I always cancel the y. All right, so if I'm going to cancel the x's, I can see a least common multiple, okay, of 4 and 5 here. That's going to be 20. So I can get these guys into 20s if I multiply. I need one positive and one negative. It doesn't matter which one's which. So I'm going to multiply the top equation. What should I multiply that by? Let's just try 5. We're going to get negative 20x plus 25y equals 5. All right, so now let's look at the second equation. I want to make these guys cancel, so I need this to be positive down here. I better multiply by negative 4. And by doing that, the x's are going to cancel because that's going to give me a 20x, and they're going to cancel eventually. But you can't forget the rest of the equation. We get minus 28y equals negative 20. So right now you can add these two equations up. Draw a line, they cancel. Negative 3y equals negative 15, and then we get y equals positive 5. You can plug it in either equation. When you do that, you'll get x equals 6, and then when you put them together, your solution is x equals 6, y equals 5. All right, we have 4 more examples to do. Why don't you try these two? I'm going to give you a hint. This one's elimination, this one's substitution. Then we'll go over them. Go! Pause the video. Okay, number 9. What did we do? Well, I saw the x's. I can get those into 12s, so I multiply the top equation by negative 3. Here's what I get for that. Bottom equation by positive 4. That'll give me a positive 12. All right, so you multiply the entire equation. Here's what we get. Add them together. 9y equals 50.4, and we divide, we get y equals 5.6. For the x, I just use the first equation, plug it back in, and we get x equals 2.1. So our answer is 2.1 comma 5.6. X is 2.1, y is 5.6. Okay, number 10, if you can notice here, the x is already solved for all by itself. All right, so we need to plug this into the other equation. All right, so let's see what that looks like. Okay, so as you notice, the green part here, that's what that x is right there. Okay, so now it's distributive property. We're going to get 6y minus, what do we get here? 7.2 plus 6y equals 19.2. All right, so we can add the 6y's together. That's combining like terms. Minus 7.2 equals 19.2. Let's add 7.2 to each side. So that's going to give us 12y. They're going to cancel. Equal sign. What do we get here? 26.4. And then if we divide, y will equal 2.2. Okay, so I'm going to go back to the first equation here. X equals 2y minus 2.4. I'm going to plug that y right there into the y value right there. So we get 2 times 2.2 minus the 2.4. This is going to equal, what, 4.4 minus 2.4, or x is going to equal just a regular old 2. So, number 10, we're looking at x equals 2, y equals 2.2. It's about as good as it gets.
Ain't nobody got time for that.
Okay, finally our last 2 examples, 11 and 12. What I want you to do is pause the video, solve each of these. I'll give you a hint. First one substitution, second one should be elimination. Solve them, see what happens. Pause the video, go! Okay, so for number 11, that's obviously substitution. It's 2 times, what do we get? We have x equals 12 minus 3y, so you plug that in. Let's get rid of those lines right there. We get 12 minus 3y plus 6y equals 24. When you solve it, all the variables go away. You get 24 equals 24. Huh? Remember this? This is called infinitely many solutions. Let's look at the next one. Multiply the top equation by negative 2 so we can get 6's in the x. That makes positive 6, negative 6. They cancel out. You get 0 equals 10. That's no solution. Let me talk through this. When does 24 equal 24? It always does. Okay, this is called infinitely many solutions. You can also call it an identity. Okay, identity. We did that in Algebra 1. We called it identity, but it could be either one. All right, that's when they're all the same after the variables cancel out. 24 always equals 24, so that's an identity or infinitely many solutions. Okay, on the flip side, when the variables cancel out, we get 0 equals 10. When will 0 equal 10? Never, so you write no solution. So, in conclusion, if the variables cancel and each side of the equation is equal, then we say there is infinitely many solutions. You can also say identity. Okay, suppose you're solving along and the variables cancel out and then each side of the equation is not equal. Then we say there is no solution. A lot of students will just write this for every single problem. No, most problems have one solution. Okay, 2.15.6 or whatever we got before, 6.5. That's most systems will have one solution. But there are times when you have many solutions or no solution, and that's when all the variables cancel out. Whew. Sorry this was so long. Had to make it interesting. Hey, a big shout out to Faith here in Baumholder. She's the one that said basically,
Ain't nobody got time for that.
yep, didn't have no time for that. This is Mr. Kelly in Baumholder. Remember, it's nice to be important, but it's more important to be nice. So